Kids, Shubhamangalam at Legal Scholars. Myself, Sukdeep. I'll be taking class 9 physics chapter 1 matter. And I also mentioned the page number again over here. It's page number 3. In the previous video, I have discussed about page number 1 and page number 2. We have covered the topics and the content on those pages. Now we are going to discuss page number 3. And we start off with the properties of gases over here, which is gases properties. When we have studied about them in the earlier classes, we come to a conclusion that gases do not have a definite shape and a fixed volume. That's because there are too many reasons behind it. One prominent reason being that the intermolecular distance between the gaseous molecules is too huge. When we compare them, okay, when we talk about the properties of solids, liquids and gases, we know that solids have a definite shape and a fixed volume. We know that liquids do not have a definite shape but they have a good volume, whereas gases, they do not have either a definite shape or a definite volume. So now we will be talking about one famous gas over here, which is compressed natural gas. From the name itself, you understand that it is natural gas in compressed form. So where do we find this natural gas? This natural gas is obtained from areas such as oil extraction fields. So for example, there is a field area where there is oil extraction taking place. So near these oil extraction places, natural gas will be evolved, and this natural gas will be compressed under certain temperatures and pressures to form the resultant product, which is nothing but compressed natural gas. Now where is this compressed natural gas being used? It is being used in automobiles. But why? Because it is energy efficient, it is cost efficient, it has an easy way of formation, it is available in abundance when compared to the other fossil fuels like the diesel, petrol and all, and it's more eco-friendly in nature. And now let's look at the two questions I have written on the board. It is, does CNG have a fixed volume? Do you think any gas can have a fixed volume? No. So how can CNG have a fixed volume then? So the answer for this will be no. Basically, these questions are actually present in your textbook. So if you have your textbook with you right now, you can also refer to the pictures which are given over there, like the CNG tank, which is built inside the car, and there is also CNG fuel stations. Such pictures are available in the textbook. Please refer them for much better knowledge. And yes, the answer for the first question over here will be, does CNG have a fixed volume? The answer is no, because CNG is a gas and gases do not have fixed volume. The second question here is, does CNG have a definite shape? Do you think any gas has definite shape? Is it rectangular, triangular, circular in shape? No. Of course not. So here the answer will also be no. So we come to a conclusion that all the gases present around us do not have a fixed shape or a definite volume. So the next topic that we will be discussing over here is compressibility. Compressibility here is nothing but the dictionary meaning of compressibility is bringing things quite closer to each other, like squeezing them, like bringing them in a smaller form. For example, you must have seen the slinky when you were really young and used to play with it. It is nothing but a spring-like structure that I have drawn over here. I'll make it a bit darker for you so that it is much more clearer. So this is nothing but a green color slinky or a toy-like thing. When you bring it very closer, they get compressed to each other, and when you release them, they just move apart. So now here we have the example of a syringe. So where do you find the such syringes? Yes, that's a good guess. You find them in hospitals or clinics. The doctor uses a syringe to inject, the required thing in your body, like a TT injection. Whenever you are, whenever you have got hurt or something, you get a TT injection, so that doesn't get septic. So basically, apart from all that, let's come back to the chapter. Yes, we are taking the example of a syringe over here, and in this syringe, I will press it over this nozzle over here. Okay, I'm going to press it over here, and I know that the syringe is empty. This means it is not really not containing anything. What it contains is nothing but air. Can you see air around you? No. Okay, so basically an empty syringe is nothing but something that is filled up with air. Okay, so now when I'm going to press the nozzle, I see that I can easily press the nozzle. I find no difficulty while pressing an empty syringe. Now in the second case, if I take some water and I fill the syringe with the help of the nozzle over there, I fill the syringe with water. What is my second case over here? I am going to fill up the syringe with water, and after filling it up with water, I'm going to try pressing the nozzle again. So I understand, when I compare both the cases over here, case 1 and case 2, like it was easier to press the syringe in the first case. Of course, air is much more lighter when compared to water. Air is a gas, water is a liquid. Now in the third case, we will keep the syringe around, somewhere around us, and now we are going to pick up a piece of wood, and I will try squeezing the piece of wood by pressing both the corners. Is the piece of wood going to squeeze up? No, it is not going to squeeze up because it is a solid. So what conclusion do you come to? That the compressibility rate of gases, liquids and solid is something like this. The compressibility rate of gases is much greater than liquids, and the compressibility rate of liquids is much greater than solids. So if you have a textbook with you right now, please note this down over there. This is something really interesting that you need to know so that you understand further concepts. So this is basically the compressibility rate. Compressibility in basic dictionary meaning is nothing but squeezing or bringing the particles together. So winding up with you guys today, it is, we have discussed two topics. It is CNG, compressed natural gas, and the second topic is basically compressibility, and we have also discussed the compressibility rate of gases, liquids and solids. Thank you.